Hello everyone, in this video we'll look at the pigeonhole principle. The pigeonhole principle is extremely important in mathematics and it is used extensively in solving statements, in solving problems and proving statements. However, we will use it in counting and it is related to this chapter. So what is the pigeonhole principle? Well, basically the pigeonhole principle, or the general idea of pigeonhole principle, says that if you have n items and m containers, so n items and m containers, with n being greater than m, meaning you have more items than you have containers, then at least one container must contain more than one item. That is the general idea of the pigeonhole principle, and this may sound very intuitive, but as I said, it is extremely important in mathematics, and we will see how it is used in solving problems. And it is called pigeonhole principle because the principle was first used with pigeons. So imagine you have pigeons and you have holes. If you have more pigeons than you have holes, then one of the holes must contain more than one pigeon. As you can see, it is very simple, but you'll see how important and how effective it is in solving problems. So let me give you an example on how the pigeonhole principle can be used in solving problems. Assume you have a mixture of blue and green gloves. What is the minimum number of gloves needed before we get a pair of the same color? Pause the video and think about it. So you basically have a mixture of blue and green gloves. What is the minimum of glove you can take out from this mixture before you get a pair of the same color? Pause the video and think about it. Well, welcome back. I hope you got it right by using the pigeonhole principle. So imagine we have a mixture of blue and green gloves. If I take out one glove, I have a glove, either it's blue or green. Let's assume it's blue. If I take out another glove, we will assume it's either blue or green. Let's say it's blue. If it's blue, then I have a pair of gloves. If it's not blue, it's green, then I don't have a pair of gloves. In this case, we are not done yet because there's a 50% chance that we don't get the same color that we got in the first time. However, if we pick a third glove, it is either blue or green. So we don't have any other color. So it's either blue or green. If it's blue, we already have a blue glove and we get a pair of gloves. If it's green, we already have a green glove, so we get a pair of gloves. So the minimum number of gloves needed before we get a pair of the same color is 3 gloves. By the pigeonhole principle, if you have n items and m containers, if n is greater than m, then we are bound to have one or more than containers containing more than one item. So for gloves, you have 2 slots. You pick one, it is one color. You pick the other one, let's say it's a different color. If you pick the third one, it has to be one of those 2 colors. It has to go into one of those 2 containers. And as you can see, how we can use the pigeonhole principle in solving these kind of problems. So let me give you some more complicated examples, and let's see how we can use the pigeonhole principle in solving them. Let's say we have this problem, which is called the birthday problem. And basically it says that what is the minimum number of people you can have in a room before you can have a duplication in their birthday, meaning that what is the minimum number of people you can have before 2 of them have the same birthday? Well, the answer is 366 if the year is 365. And why? Well, if we have 365 people with different birthdays, then all of them will fit in one day of the year. However, if you have 366 people and all of them having different birthdays, there has to be 2 of them that have the same birthday because we only have 365 slots. If we have 366 pigeons, one container or one slot has to have more than one pigeon or more than one birthday. So basically, the minimum is 366 people in order to have a duplication and birthday if you have people in a room. Okay, so another problem that we have that is similar to the birthday problem, it's bigger and we can use the pigeonhole principle in it, is the hair counting problem. And basically it says, what's the minimum number of people you can have in a city before you have a duplication in the number of their hair on their head? Well, basically, let's say the maximum number of hair someone can have on their head is, let's say it's 3 million. So on Earth and in humanity, there cannot be more than 3 million hair on someone's head. That's the bound. Well, let's look at a big city like London and New York. What's the minimum number of people you need in order to have a duplication in the number of the hair on their head? Well, basically you need, by the pigeonhole principle, you need 3,000,001 in order to have a duplication, the number of hair on people's head. And why? Because you have 3 million slots or 3 million different number of hair on people's head. So on the first one, you have a person that has 1 hair on their head. On the second, you have 2 hair, third one, 3 hair, until you get to 3 million. And if you have 3,000,001, then that one has to have the same amount of hair on their head as one of the 3,000,000, because you have 3,000,000 containers and 3,000,001 pigeons. Then there has to be one container that contains more than one pigeon. That's basically the hair counting problem. The same goes for the Thanksgiving turkey problem. And basically it says what's the minimum number of turkeys that you need in order for two of them having the same weight, rounded to the nearest digit, knowing that the maximum weight on a turkey is about 37 pounds. Well, I hope you guessed it, and it's 38 turkeys. You need a minimum of 38 turkeys in order to have two turkeys that have the same weight. Lastly, we have the card picking problem. It says that what's the minimum number of cards you can pick before you have two cards that are the same kind, having a 52 deck of cards. Well, you need 5 cards, because let's say the first card you pick is a heart, the second card that you pick it's a club, the third card you pick is a diamond, the fourth card you pick is a star. The fifth card that you pick, it has to be one of the 4. So now you have 5 pigeons and only have 4 containers. So one of the container has to have more than one pigeon or more than one card. So you need the minimum of 5 cards in order to have a duplication, or in order to have 2 cards that are the same. And as you can see how we used the pigeonhole principle in solving these kind of problems, in solving the birthday problem, in the hair counting problem, in Thanksgiving problem, and in the card picking problem. And there are other problems that you can find online or in mathematics that it uses the pigeonhole principle in counting and in solving statements and those kind of problems. And basically it says that if n items are put in m containers with n being greater than m, then at least one container must contain more than one item. And this is the general idea of the pigeonhole principle. And this is it about this lecture. See you in the next one.